Looking at quadratic word problems, there's really three different things that you're going to be solving for. So you're either going to be given x and you're going to be finding y, where you just sub into the equation. You're going to be given y and then you find x by either factoring or using quadratic formula, or you need to find a max-min value by completing the square or using the x-intercepts to find the vertex. So we're going to do two questions here. The first is kind of a combination of all of them, and then the second one is just a common type of question. So looking at this, we've got the height of a toy rocket is modeled by the formula h equals negative 4.9 t squared plus 60t plus 3, where h is the height above the ground in meters and t is the time in seconds after it's being launched. So the first question is, what is the height of the rocket from launch, or it's being launched from? This is going to happen at t equals 0. So when t equals 0, though it hasn't been launched yet, but the moment that it gets launched, we're obviously adding time. So if we just make t equals 0, we can then find out what the height was that it was launched at. So for this, all we're going to do is sub in that t equals 0, and our height would end up just equaling 3, because 0 squared is 0. 60 times 0 is 0, so we're just left with 3. Okay, the second question says, when does the rocket hit the ground? Well, for this one, the rocket hits the ground when h equals 0, because the height equals 0. So what we need to do is make h equals 0, and then we're going to work through the quadratic formula. Because we have a decimal at the start, probably can't factor it. Some of the times you can, but for the most part, if there's a decimal at the start, you're just going to go right into the quadratic formula. So here we're going to have negative 60 plus or minus the square root of 60 squared minus 4 times negative 4.9 times 3, all divided by 2 times negative 4.9. So I'm going to do a little bit of work, and then I'm going to kind of just show you the answer here. So simplifying under that, two negatives make a positive. So we get 3658.8 divided by negative 9.8. And then our two numbers, so we would get t equals 12.29 or t equals negative 0.05. We can't have a negative, so that one's gone. So that means that it's hit the ground after 12 seconds. We can't go back in time to let it hit the ground. Okay, so therefore, after 12.29 seconds, it hits the ground. Now the next question is asking us, so I'm just going to create another tab here just so we have a little bit more space. But the next question is asking us, what is the maximum height of the rocket and what time does it reach this height? Now we could complete the square for this, but the numbers are really hard. Like, these numbers are not easy to complete the square with. So what we can actually do is we can use our x-intercepts that we've just found, the negative 0.05 and the 12.29, and we can just find halfway in between them. We know when we're dealing with a parabola that our parabolas are going to be symmetrical. So if we hit the ground here and here, so this would be 3 where we started from, this would be negative 0.05, this would be 12.29. We know that halfway between negative 0.05 and 12.29 would give us our vertex, and that's when the highest point happens. So what we're going to do is we're going to find the x of our vertex by adding our two x-intercepts together and dividing by 2. So we've got 0.05, negative 0.05, plus 12.29, and we're going to add them together, and then we're going to divide that by 2, and you should get 6.12. So after we get 6.12, we're going to take this equation. So H equals negative 4.9. And then we're going to sub in 6.12 squared plus 60 times 6.12 plus 3. And then we're going to just add all of that together. Make sure when you're multiplying, you have their negative on your 4.29. I'm going to give a little bit. I'm going to give this line, and I'm rounding here, but we've already rounded in this question, so it's not super important. But you want to make sure that you've got all of your numbers correct, so that when you go through, you actually get the right answer. So now we're going to get an answer of 186.7. So our vertex, our highest point, therefore max height is 186.7 meters at 6.12 seconds. For how many seconds was the rocket above 100 meters? This is a tough question. What we're going to do is I'll add one more slide here. We're going to do the exact same thing that we did before. So we've got H equals negative 4.9 t squared plus 60t plus 3. And I'm going to have you work on this question. But what we're going to do is we're going to substitute 100 in. 4.9 t squared plus 60t plus 3. And what that's actually going to do is if we were to graph it, you're going to go through, you're going to get two answers for t. Here's our equation, or here's our graph roughly. Here's the middle. 100 is going to be right here and right here. So we're going to get two answers, this answer and this answer. And we need to find the difference in those two answers, because the question's asking for how many seconds was it above. If we solve for those two answers and then find the difference between them, we'll know that. This is the same as this question here, but we now just have a different time. Okay, looking at the second question. The Quadratic's Cup is a coffee shop where Matthews can buy delicious beverages. The average customer, so we've got 95 customers a day, and we sell for $2. So right away, without even kind of looking at the question, I know that I'm looking at a revenue question, and revenue is always going to be sales and cost. Okay, now there's going to be some sort of variation on it, but our revenue here, I think A is actually asking us for the revenue. Write an equation to model this. So we're going to have R as our revenue. Our sales are how much we're selling. We're selling an average of 95 a day, and we're selling it for $2. Okay, so on average, we're selling 95 things for $2 each day. So we would make $190 on average. However, the math nerds who own the shop discover if they decrease the price by 10 cents, they'll get 5 more customers. Well, if we're decreasing the price by 10 cents, that's going to be here, and we're adding 5 customers, that's going to be here. That only shows one situation. So what we actually need to do is we need to change where we're going to have this equation, or how we're going to write this equation. We need to have a variable. So what our variable is going to be is let x be not the actual increase in price, but the number of increases or decreases. So the number of decreases. And what that does is every time I decrease it by 10 cents, I increase it by 5 customers. If X was equal to 2, I'd decrease it by 20 cents, but I would increase to 10 more customers. So let's see what B says. It says how much, or what should the price be to earn $176? Well, earnings is R, so we're going to have 176 equals all of this. 95 plus 5x times 2 minus 0.10x. Okay, so we're going to have to do some math here. We're going to have to put everything on one side. We're going to expand those brackets out. So we're going to have 0 equals. I'm going to expand the brackets and just write it into a bracket here. So we've got 190. And then we're going to have minus 9.5x. 95 times 0.1 is 9.5. Plus 10x. 5 times 2 is 10. I'm just doing FOIL here. And then 5 times 0.1 is going to give me 0.5. And we're minusing 0.5x squared. And then from all of that, I'm subtracting 176 because I brought the 176 over. Then we're going to get our collecting like terms. So we're going to have 190 minus 176. We're going to get 14 at the end. We've got negative 0.5x squared, which makes sense because we want to have like a maximum value because there would be a maximum that we could do. And then plus 0.05x. And there's our equation. We've collected all our like terms. Now, we need to take that equation and we need to find out what our values would be. So we need to either factor it or we have to use the quadratic formula. So due to the fact that it's got decimals, I'm just going to use the quadratic formula. So just writing this back out. So we're going to have x equals negative 0.5 plus or minus the square root of 0.5 squared minus 4 times negative 0.5 times 14, all divided by 2 times negative 0.5. So then when we go through, we're going to get negative 0.5 plus or minus. Now we've got to put all this into our calculator. So 0.5 squared is 0.25. And now again, the double negative is where people mess up. We've got 4 times negative 0.5 would be positive 2 now because we had 2 negatives. Then we're timesing it by 14. And then we're adding that 0.25. So we've got 28.25 under the brackets. Let's close that. All divided by negative 1. So all that's going to do is going to change the sign at the end. So then we're going to have x is either equal to, so the square root of all of that is about 5.3. So we've got negative 0.5 minus 5.3 divided by negative 1, or x is equal to negative 0.5 plus 5.3 divided by negative 1. So one case here, negative 0.5 divided by all that is going to give me 5.8. Over here, we would have negative 0.5 and then divided by negative 1, we're going to get, 0.5 plus 5.3 divided by 0.1, so we're going to get negative 4.8. We can't have a negative amount of increases or decreases. We'd actually be increasing the price. So we want to find out how many decreases we have, which is going to be this one. This would actually work if we were talking about increasing the price. Okay, so if you decrease the price negative 5 times, you're actually increasing the price. And due to the fact that the question says we're only using this, to get a revenue here, we'd be between two values. So you could say 5, but you'd likely have to say 6 decreases in price. Well, 6 decreases in price, actually, we're decreasing the price. So if we have 6, therefore 6 decreases. And if the decreases or the price was not 6, 2 minus 0.1 times 6 is going to end up being 1.40. and that's going to be there for $1.40 should be the cost to produce that.